session, we'll be looking at a few problems dealing with mostly differential equations and how to go about solving them using different methods, right? So looking at this first example that we have here, we have to use the separation of variables method to solve the differential equation that's given here. And we have dy over dx is minus 1 plus x times 1 plus y squared is equal to 0. And please note that this is not a negative. This just might as well be an asterisk. Okay, so it's not a negative. Right, so how do we go about this? Well, we know that that means that we have to bring all the terms in x on one side and all the terms in y on the other side. That's what the separation of variables literally means. So that means that the dy will stay there, right? And let's leave the dx there for now as well. And this will be equal, dy over dx is equal to 1 plus x times 1 plus y squared, right? So now let's bring in the y onto the left-hand side. So that would mean we have dy over 1 plus y squared, right? And we bring in the dx to the right-hand side is equal to 1 plus x dx. And at this point, that's when we introduce the integral on both sides, right? So let's introduce the integral on the left-hand side. We have dy, the integral of dy over 1 plus y squared is equal to the integral of 1 plus x dx. Now this is equal to what? Well, we know that this integral on the left-hand side is looking, right, similar, right? And if you go back to when we're dealing with integrals, you'll see that this integral is nothing else than the integral of arctan of y, or tan inverse of y, right? So arctan of y is equal to what? Is equal to the integral of 1 plus x, which is just which is just x plus x squared over 2, plus our constant of integration, which is unknown at this point, right? So the reason why we didn't put in the constant of integration on the left-hand side is because they'll just cancel out with the other a constant of integration on the right-hand side. So we just represent that difference by c. Okay, so that should not be such big of a problem, right? So then we express this expression in terms of y. So if arctan of y is equal to that, y is equal to, therefore, tan of x squared over 2 plus x plus c, right? So that is the final answer. So hopefully this makes sense. Let's move on to the next one. Again, here we have to use separation of variables. And the question is, we have the square roots of 1 plus x squared over 1 plus y multiplied by dy over dx is equal to minus x. And we are asked to use the separation of variables once again to solve this. So what we'll do here is, let's bring all the terms in x to the right-hand side, since we already have the minus x there. So on the left-hand side, we'll have then dy over 1 plus y being equal to minus x divided by root of 1 plus x squared times dx. Okay, At this point, we can introduce the integral on both sides. Then we have the integral of dy over 1 plus y is equal to the integral of negative x over root of 1 plus x squared dx. And now the integral on the left hand side is a straightforward one. That's just ln of y. The integral on the right hand side, on the other hand, is not as intuitive to sort of notice. So what we can do here, right, is use substitution, right? So let's leave that like that, and let's solve it separately for now. The integral of 1 plus x squared, the integral of minus x over root of 1 plus x squared dx, and we let u be equal to 1 plus x squared. Du is therefore equal to 2x dx. That means that the integral is equal to negative du over 2 all over root of u, which is just equal to what? We'll take the negative 1 over 2 here, which is a constant, out of the integration, and we'll be left with du over root of u, which is equal to negative 1 over 2 multiplied by u to the negative half plus 1 divided by negative half plus 1. Obviously, we'll introduce the constant of integration as well, plus c, right? So then this is equal to half plus 1 is just, negative half plus 1 is just half. And that half here is going to cancel with that half there, so we'll be left with minus root of u plus c. And that would mean that our ln of y is therefore equal to minus root of u is just 1 plus x squared, so let's just substitute in minus root of 1 plus x squared plus a constant of integration c. And that would just mean that oh, my mistake. This should be ln of 1 plus y. Sorry. So ln of 1 plus y. Same here, ln of 1 plus y. And therefore we have 1 plus y is equal to e to the negative root of 1 plus x squared plus c. And that means that y is just e to the negative root of 1 plus x squared plus c minus 1. And this is our final answer. Okay, so hopefully it makes sense. Once again, as I might have mentioned before on multiple occasions, the whole point of these examples, if you need to understand them, please try to attempt them on your own. It's all about practice. So if you practice, it will become easier and easier to understand these concepts. All right, so please just practice whenever you can, and see if you're able to solve it on your own. So moving on to the next question, now we have the integral of, well, sorry, not the integral. We actually have 1 plus x to the 4 dy over dx is equal to x cubed over y. And that's our new differential equation that we need to solve using separation of variables. And to do this, we'll just bring in all the terms in y on the left-hand side. So that would mean we have y dy there. And all the terms in y on the, or in x, sorry, on the right-hand side, which means we'll have x cubed over 1 plus x to the 4 dx. Okay, so introducing the integral on both sides, what do we have? We have the integral of y dy is equal to the integral of x cubed over 1 plus x to the 4 dx. All right, so now the left-hand side will just give us y squared over 2, okay, is equal to the right-hand side. Now we have to think about it. So you can see that the denominator, which is 1 plus x to the 4, is one order lower than the numerator. So, and whenever you have that case, you know that that means that you can easily take the derivative of the denominator to get the numerator, right? Especially in the case of these polynomials, right? So that means that you need to find the function for which you take the derivative and then you just divide by the whatever is under the function, right? So that would mean ln, right? Because remember that for all ln functions, so ln of f of x in general, when you're trying to find the derivative of that, you just take the derivative of f of x and you divide by f of x, right? So that's the rule for all ln functions. So what that means is that the integral of x cubed over 1 plus x to the 4 is just ln of 1 plus x to the 4. But now, because you can see that when you derive 1 plus x to the 4, you're supposed to have a 4 x cubed, right? So there's no 4 in our numerator here. So what we'll do to compensate for that is just divide by 4 and then add our constant of integration, of course, right? So what does that mean? Well, it means that our y is therefore equal to root of ln of 1 plus x to the 4 over 2 plus 2c, right? Okay, so, and that is our final answer. All right, so then moving on to the next question, we have the equation dy over dx minus x to the ey, sorry, minus x times e to the y is equal to 2 times e to the y. And we are given an initial value of y at 0 being equal to 0. Okay, so in this case, we have an initial value sort of problem. And what that means is we integrate the same way we've been integrating, but at the end, we use the initial value to just find the value of our constant of integration, right? So that's how this works. So going back and using the same logic, we just bring in all the terms in y on the left-hand side. So let's do that. Then we have dy over dx plus 2e to the y minus x times e to the y being equal to 0, which means that we have dy over dx equal to x e to the y minus 2e to the y, which means that we have dy over dx, being equal to x times, oh, not x, but rather e to the y times x minus 2. And bringing the terms in y on the left-hand side, we have dy is equal to dy over e to the y is equal to x minus 2 dx. Introducing the integral on both sides, we have dy over dx over e to the y being equal to the integral of x minus 2 dx, which is therefore equal to the integral of 1 over e to the y is just the same as the integral of e to the negative y, which is just equal to negative e to the y, negative y. And that is equal to the integral of x minus 2, which is just x squared over 2 minus 2x plus c. And this is therefore equal to e to the negative y being equal to 2x minus x squared over 2 minus c. Introducing ln on both sides, we have negative y is equal to ln of of 2x minus x squared over 2 minus c. And that just means that y is equal to negative ln of 2x minus x squared over 2 minus c. And there you have it. So that's that. And that is the end of this problem, right? So that's the final solution. Now moving on to the next set of differential equations, but now instead of using the separation of variables, right, which is not always easy or even possible to use in some problems. In this case, now we have to use a method that's called the integrating factor. And what that means is that we have to modify the differential equation in such a way that we get it in the form of, in this general form, right? So the general form dy over dx plus p of xy being equal to q of x. So this is the general form that we're trying to get our differential equation into. And as soon as we get it into this form, then we have to find the equation mu, which is just e to the integral, right, of p of x dx And as soon as we find mu, our final solution will be y being equal to 1 over mu multiplied by the integral of mu times q of x dx, or q of x, which is there. Right? So that is the combination of these three processes gives us the method that's called the integrating factor method. Okay, or IF, which is usually how it's represented in the literature. So what that means is that we need to get our differential equation in that form. So let's see. First, we need to divide by x on all sides so we can get rid of the x next to the dy over dx. So that means that our equation becomes dy over dx plus 2 over xy is equal to 4x. Okay, if you divide by x across all terms. And immediately you can see that we have already gotten our equation into the general form that we're looking for. And that means that our p of x is equal to 2 over x, and our q of x is just equal to 4x. Okay, so we have that. What does that mean? Well, it means that our mu is equal to e to the integral of p of x dx, which is equal to e to the integral of, in this case, 2 over x dx, which is just equal to e to the ln, or rather 2 ln of x, which is just the same as e to the ln of x squared, right? Because you can bring in the 2 back under the ln, which becomes an exponent, so ln x squared. And this is just equal to x squared, right? Using the general sort of rule that applies to exponential functions. When you have e to the ln of f of x, that is just equal to f of x, right? Hopefully you are aware of this rule. So keeping that in mind, we've already got our mu, right, which is x squared. So now we need to get our y, right? And remember that our y is just 1 over mu, right? We have the formula there. 1 over mu, so 1 over x squared, multiplied by the integral of x squared, which is mu, multiplied by q of x, which is 4x dx, which is just equal to 1 over x squared multiplied by the integral of 4x cubed dx, which is 1 over x squared multiplied by x to the 4 plus c, right? Constant of integration. And this is therefore just equal to, well, we can even leave it like that. And we can just use our initial value now, which tells us that, oh, and my mistake, I think we forgot to do that for the previous problem as well. So in the previous problem, we're supposed to use the initial value that's given to us. Y of 0 is equal to 0. So, sorry, going back to this, y of 0 is just equal to what? It's equal to negative ln of 2 times 0, 0, minus 0 squared over 2, 0, minus c. And that is, we are told, is equal to 0. So we have basically minus ln of minus c is equal to 0. It just means that ln of minus c is equal to 0, which just means that c, or rather minus c, is equal to e to the 0, which just means that c is equal to minus e to the 0, which is minus 1. So our constant c of integration is minus 1. Right? So what does that mean? Well, it means that we have our y now function is equal to negative ln of 2x minus x squared over 2 minus minus 1, which is plus 1. So that is our final equation. So going back to this one, we do the same. We are given that y of 1 is equal to 2. That just means that, let's double check, yeah. And that just means that when you substitute 1 into y of x, which is 1 over 1 multiplied into 1 to the 4 plus c is equal to 2. It just means that 1 plus c is equal to 2, meaning that c is equal to 1. We found our constant now, meaning that our function y is therefore equal to 1 over, x squared multiplied into x to the 4 plus 1, which is our